Hi, my name is Terry. This is my term project for AIT381 and my topic is video and audio compression. When video signals are transported over an IP network, they are usually compressed. Compression means to reduce the number of bits that are required to represent the video image or audio file without removing useful information. There are many items that we use daily that incorporate some type of compression. Some examples are digital cell phones, digital TV and HD TV, satellite TV, digital cameras, DVDs, and MP3 players, just to name a few. I will now discuss some of the items used in a compression process. This slide shows a simplified block diagram of a compression system. There is information going into the compression engine, which is called an encoder. Once through the encoder, the information is compressed and sent on its way. When the information reaches its destination, it goes through a decompression engine, which is called the decoder. Compression techniques can be broken into two broad categories, lossy and lossless. Lossless compression is used when it is important to preserve every bit of the original material. Lossy compression is used when it is important to maintain the meaning of a signal, but not every bit. The biggest drawback to lossless compression is that it is not guaranteed to produce an output that is significantly smaller than the input. Lossy compression is designed to permanently remove less important information. For video and audio compression, lossy compression and something called perceptual coding is usually used. Perceptual coding is taking advantage of the limitation of the human senses to make the perception of an image or sound similar to another. You have to be careful with the amount of compression being used. As a file becomes more heavily compressed, the amount of distortion increases and you will lose fine detail. This slide shows the result of excessive compression. The Moving Pictures Experts Group has developed some of the most common compression systems for video around the world and given these standards the common name of MPEG. Not only did this group develop video compression standards including MPEG-1, users of any MPEG system will quickly encounter a variety of frame types including I-frames, P-frames, and B-frames, as well as the term GOP, group of pictures. An I-frame, which stands for intra-coded, is the only kind of frame that can be decoded by itself. There is no reference made to any of the other video frames. A P-frame, which stands for predicted, will take 2 to 4 times less data than an I-frame of the same image. A B-frame, which stands for bidirectional, will take even less data than a P-frame, a further reduction by a factor of 2 to 5. Selecting a suitable GOP length and GOP pattern can have a big impact on a video network. If the GOP is too short, then the encoded bit stream will occupy excessive bandwidth because of the increased number of I-frames, or video quality will be decreased because I-frames are less efficient at encoding information than P-frames and B-frames. If the GOP is too long, then the video stream will be hard to work with and less tolerant to transmission errors. MPEG-1 was developed in the early 1990s and was the first standard created for video compression by the Moving Pictures Experts Group. It was intended for use in creating video compact discs. MPEG-1 does not support interlacing or high-definition video, so it cannot be used for PAL, NTSC, 720p, or 1080i video. MPEG-1 is still in use today in low-cost surveillance cameras and some web video applications. MPEG-2 is one of the predominant standards for MPEG video today. It was approved in 1996. MPEG-2 offers some significant advances over MPEG-1. MPEG-2 supports interlacing, so standard NTSC and PAL signals can be supported at full resolution. It supports a variety of different resolutions and performance profiles, so a variety of applications including HD television, both 720p and 1080i, can be accommodated. MPEG-2 supports multiplexing a number of video and audio streams, so applications like multi-channel satellite television is possible. MPEG-2 also supports 5-channel audio, known as surround sound, and the Advanced Audio Coding Standard. MPEG-4 incorporates a wide range of new technologies for video compression that have been developed in the past decade. MPEG-4 takes advantage of increases in processing power that have become available, which allow a 50% reduction in bandwidth, and have enabled new applications such as HD video delivery over the internet, Blu-ray discs, and IPTV networks. MPEG-4 achieves many of its advances in compression efficiency through the introduction of new video objects created by the encoder. One key aspect of MPEG-4 technology is the ability of the encoder to assemble an image from multiple types of source material to form a composite image that combines elements from both natural and synthetic sources. MPEG audio compression. There are 3 layers of MPEG audio: Layer 1, Layer 2, and Layer 3. Layer 1 is the simplest compression system. It uses 384 input samples. Layer 2 uses 1,152 input samples and eliminates some of the redundancy in Layer 1. Layer 3 uses the same number of samples as Layer 2, but it uses them more efficiently. MPEG Advanced Audio Coding is available only with MPEG-2 or MPEG-4 video streams. It supports up to 48 audio channels, including 5.1 audio. With so many different types of MPEG available, I'm sure you're wondering what version you should use for your application. Well, it depends on your specific application, but I can give you some guidelines to go by. MPEG-1 has been in existence for a long time and requires less processing power than either MPEG-2 or MPEG-4. But nowadays, most PCs have enough processing power to handle the advanced codecs, and therefore MPEG-1 is not used in new applications. MPEG-2 is commonly used in contribution, distribution, and delivery networks and is the only compression format approved for digital TV broadcast in the United States. MPEG-4 offers a huge range of operating profiles and levels for a wide variety of applications. MPEG-4 has a number of advantages for computer-generated video and has already deeply penetrated IP video streaming applications. So do some research, weigh out the pros and cons, and the difference in money for the various types, and good luck.